Hi guys. Okay. Low key, I'm gonna be honest, I feel really tired, but I didn't mean to do this. So I am gonna do it. It's like 7:40. I don't know why I'm so tired. But yeah, since VC1 window is over, I did manage to get a copy of the test. It's written on, and I'm not gonna expose whose test it is. But I do have a copy, so I'm gonna try to see if I can go over all 60. Not just actually live solve the problem, but actually walk through what the idea should be like, how you should be solving it. For the record, I have not looked at the test yet, so I do have the key open. There's a very good chance I mess up problems. So just bear with me. But I did also watch the Itzy music video for Imaginary Friend, so I am slightly more awake now. Let me see if I can get my screen to share properly. Okay, bingo. Oh, okay, did not mean to show the key immediately. Okay. Okay. So I have Clecky open in case I need to draw on some stuff. I'll just screenshot the problem and copy it there. But okay. So first question, we have two people, 10:10 and 11:05, tea for 2:45 and bottle for 1:45. Dessert, they got two orders of coffee for 3.25 each, and the tax rate was 8.25%. $40 with the overage going towards tip. Okay, that's weird wording. Okay, so we just need to figure out what the pre-tax total is. So we have 10:10 and 11:05. I need to like move my face out of the way on this. So we have 10:10. Oh my God, 10:10, 11:05. What else do we got? 2:45, 1:45, plus 2 times, I believe it was 3:25. Yes. Okay. So this is our pre-tax total. And it says that the tax was 8.25%. So multiplying this by 1.0825, this is how much the meal actually cost. But Chuck decided he's going to pay $40 and any remaining would go to tip. So 40 minus this answer is that much. This is the tip. And if we divide this by the pre-tax total, so that 31.55 times 104%, 18.53. So D looks right. Yeah. So number one, add up all the prices, you get a pre-tax total. Figure out, use the tax rate to figure out the subtotal? Total, I guess. I can't remember these terms. And then subtract from 40, find the tip, and then divide by the pre-tax, and then bam. Okay. Number two, consider the line segment with endpoints -8, -3, and 6, 7. Perpendicular bisector. Here we need two important things, the slope of AB and its midpoint. So what we can do for the midpoint is here, I think this is a good example of one of those problems I'm going to copy into Clucky. It's just a website that my sister used to draw in a bunch, and I love using this for like problems and stuff. Okay, so first thing we want to do is midpoint's really easy here. So our midpoint, and for the record, this is a trackpad, so my handwriting is going to be terrible. But okay, so midpoint, anytime you want to find the midpoint of 2 points, for the x and y coordinates, you can just take the average of their values, aka the median value. For -8 and 6, this value is just going to be -1. And for -3 and 7, this value should be 2. Again, just add the numbers, divide by 2, that's your midpoint. Then we also need to find the slope between A and B, like if there's a line going between them. So we notice that the change in y is +10, and the change in y is +10, change in x is +14. So 10 over 14, or we get our slope is 5 over 7, right? Now, what does this tell us? If our slope is 5 over 7 and we want the perpendicular bisector, we need the negative reciprocal to find the slope of the perpendicular bisector, which in this case is -7/5. And we further know that this passes through the point -1, 2. Using slope-intercept form, we can write this as y minus 2 equals -7 over 5 times x plus 1. Okay. right? So we have this, and then we're told that we want to find the y-intercept. So all we need to do is just plug in 0. 0 plus 1 is 1. 1 times negative 7 fifths is negative 7 fifths, or negative 1.4. And adding 2 should give us 0.6 as our answer. Yeah, so 0.6 would be our answer. Again, I did get this from someone else. So there may be some wrong answers here or there, but obviously no judgment. We're all trying to learn, and that's honestly one of the main reasons why I'm making this video. I should be doing my discrete math problems. I'm going to be honest with you guys, but that's too much work. Okay. Number 3, Lynn. Oh, I haven't seen Lynn in a while. But anyways, Lynn's got 53 coins, 665. Okay. Classic linear equation, system of equations setup. Okay. So easiest way to do this, and again, I'm using a TI-84. If y'all use like an Nspire or something, suck to suck, just figure out the equivalent or whatever. Okay, so we notice here that we have 3 different statements. We're told their price, we're told how many coins there are, and we're told a relationship between 2 of the quantities. So we can create 3 different equations and use a 3x4 matrix to figure this stuff out. So what we're going to do is, if we go second matrix, where's RREF? Here we go. Okay. Then we make our matrix here. Oh my God. It's been so long since I've done this stuff, and I never use this online calculator. Okay. So what are we first told? We're first told that there's 53 coins. Now, for usually in these equations, it's like something x plus something y plus something z. For this, it's way easier if we think about it as n, d, q in that order, nickels, dimes, quarters. We know that the sum of the coins is, well, there's a total of 53 coins. So that means that if we put a coefficient of 1 in each, meaning 1 times the number of nickels, 1 times the number of dimes, is very close to something else, and 1 times the number of quarters, it should just be the number of coins. Then our next part is it's worth 665 total. So 5, I'll do 0.05 for clarity. So each nickel is worth 5 cents, each dime 10 cents, and each quarter 25 cents. This should add up to 665. And this may be a bit of a rushed explanation, that's my fault. But hopefully if you write out the equations, you'll see like where these coefficients are coming from. Okay. And lastly, we know that there's 10 more quarters than dimes, which means that dimes plus 10 equals quarters. So then we have, so that's the same thing as saying D plus 10 equals Q. So D plus 10 equals Q. I just think y'all can see my history. I don't want you to see that in case there's like random stuff that comes up. What comes up? Or it's tetriostats, unfortunate. Discord, whatever. I'm getting off track like usual. Anyways, so we have D plus 10 equals Q, right? And if we want all our letters on one side, numbers on the other, we move these and we get D plus 0, or well, 0n plus D minus Q is equal to negative 10. So then this becomes our last equation. So we have 0 nickels. We multiply 1 times the number of dimes and negative 1 times the number of quarters. And this should equal negative 10. Now, what does this result mean? 27 nickels, 8 dimes, 18 quarters. We're asked to find the number of dimes, and that should be 8, D. Okay, bingo. I don't know how long it's been. I'm going to be honest with you. Okay, whatever. Okay, question 4, Amelia solving the quadratic equation x squared plus 11x plus 7 equals 0 by completing the square. What is this value of c that you need to add? Okay, so general idea for completing the square is that we want to use square binomials. So wait, this is way easier if I type. Some of the stuff is easier if I type it out. That way I don't have to draw. Took me 3 times to find the font. Okay, so the general idea is that we know x plus b squared, if we expand this, is x squared plus 2bx plus b squared. Okay, and we're trying to rewrite x squared plus 11x plus c in the same form. We notice if this 11x goes here, then b must be 5.5. the value we're adding here should just be 5.5 squared or 30.25. In general, the value is just going to be take this number, have it square it. So that should give us 30.25b as our answer. Okay, let's write it. Okay, number 5. Consider these statements. Oh, this is geometry stuff I've not seen in a while. But, okay. If a shape is a rectangle, then it is a quadrilateral. If P, then Q. If a shape is not a quadrilateral, it is not a rectangle. If not Q, then not P. And notice how I'm saying P is shape a rectangle and Q is shape a quadrilateral. So our second case is, so our first is P, then Q. Second is not Q, then not P. The name for this is a contrapositive. And this stuff is purely just memorization. Contrapositive states not Q, therefore not P. Or if not Q, then not P is a better way to phrase it. The inverse is if not P, then not Q. In other words, take this original statement and just put not, a not here and not here. And our converse is just swapping these two statements. So it would be saying if it's a quadrilateral, then the shape is a rectangle. And another cool thing is that your original statement and your contrapositive statement will always have the same truth values. So this first statement and this second statement here are actually always going to be the same thing, regardless of whether our shape is a rectangle, is a quadrilateral, is a pentagon, whatever. But our inverse or our converse may not necessarily follow that. In this case, they don't. Transpose is not a thing in context. Antithesis is an English term, which y'all will have to learn maybe at some point, which is unfortunate. But yeah. Okay, 5C. Okay, 6. If blah, 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 blah. Okay, so yeah, this is just plugging stuff into the function. So you just take 28, you plug it in here. 28 squared is 784. Minus 3 is 781. Cube root of 781 is probably like, I don't know, 9.2 or something. 781. Huh. Okay, pretty close. So then we take this, and it's what? The log of this plus 2. And that's 2.964, which does run to 3.0. Yep. Okay. Two consecutive angles in the arcs of the other 6 angles are congruent. Okay, so what does this tell us? This tells us that we have 6 angles which are each x, and then we have 2 angles that we know add up to 180. And since we don't need these angles, so we're not asked what the supplementary angles are, we don't care about this. We just care about the fact that they add up to 180. So that means that we have 180 plus the 6x equals the total number of angles in an octagon. For any regular, not just regular, any convex polygon, I believe, is the, like, I forgot the word, construct or whatever, is that if it has n sides, then the number of the sum of the angles is 180 times n minus 2. In this case, n is 8, so 8 minus 2 is 6, 180 times 6 is 1080. Then we subtract out that 180 and we get 900, meaning that each of the 6 angles sum up to 900. Thus, one of the angles is just 150. Piece of cake. Okay. Number 8, find the domain of the function. Okay, usually this is trivial, but just graph it. But the general idea is that we want to look for restrictions in when the function is defined, right? So recall that this numerator is just always going to be some value. It's never going to go imaginary. There's no reason for it to do so. But our denominator, we need to ensure never reaches 0 or negative. It has to be a positive value. By that, I'm referring to the 2x squared minus 7x plus 3. Because square rooting is 0, we'll get a 0 in the denominator, invalid. Squaring a negative number is complex, also invalid. So 2x squared minus 7x plus 3. I don't feel like graphing it. I'm just gonna graph this. I don't want to figure out, like, actually factor that, because why would you? Minus 7x plus 3. So our roots are 1/2 and 3. And between them, it goes negative, which means that between 1/2 and 3 inclusive, it fails. So C is actually the opposite of our domain. C is where the function is invalid. But this option right here, option D, Let me double check. Yeah, option D, this is where it is defined. If it's less than 1/2, it'll be defined. If it's greater than 3, it's defined. And with that, finally done with the first page. I still don't know how long it's been. I should start like keeping track of this now. Okay, I started a stopwatch. Okay. What is wrong with this image? Oh my God. Okay, I'm gonna stop sharing my screen. Let me figure out what went wrong with these images. Do 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 do. It's funny because I don't even have this like formally prepared. So it's literally just me yapping. I'm in the middle of some gesture study room and just doing this stuff. It's kind of funny. I kind of just randomly left. I was like doing nothing to be fair. And then I was just like, you know what? Let me get this done with. Okay. Enough of my yapping. Okay, Valos, let's run this again. Okay, so question 9. Oh my God, not these. Okay, I'm gonna be honest. I made a shoelace program for this, which obviously I don't have on me because of this, but I do have a shoelace program that I can literally plug in the points in here and just like find the answer. But clearly that's not feasible right now. So what can we do here? I guess best thing is just to explain how to solve this formally. Number 9, I'm not really gonna explain. I feel like y'all should be able to get, most people will be able to get the idea. Just spam Pythagorean theorem 4 times. You just figure out change in y, change in x, square root, Pythagorean theorem. You get the sign length. Repeat that 4 times. You're gonna get the perimeter. Hopefully it's, what is it? 31.2. And yeah, oh my God, my throat is so sore. Okay. Question 11. Okay, I'm just gonna mention question 11 because I did mention the midpoint thing earlier. Y'all get the same idea. It's just add the x coordinates, divide by 2, add the y coordinates, divide by 2. That gives you a and b, just add those values. Easy. Okay, question 10. Several ways to do this. I know Eric was actually not aware of shoelace for a pretty long time. So he would actually, what he would do is that, let me see if I can draw a picture accurately. What he'd do is that he would draw a bounding rectangle in this, and then he would subtract all the shapes that formed. Right? I guess this is a bit nasty because you have to form this additional shape here. But here you get a triangle, 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 trapezoid. Normally it'd be 4 triangles, but yeah. And then you would just find the area of this whole thing, subtract off those. Another way to do this, however, is just use shoelace. What is shoelace? Okay, so what we're gonna do is we're gonna take these points, write them in clockwise or counterclockwise order. It's important you write it in this order and that the shape is convex, meaning that it doesn't bend like super weirdly or something. Okay, so A is -4. So -4, 1, 5, 4, 4, -3, -3, I already forgot. 4, -3, 6. And then we just rewrite the first, our starting point again. Okay, so the idea is that for each pair of numbers, we're going to go down this way, like this, and multiply these. Yeah, we're gonna multiply these, right? So we have -16, -15. Oh my God, my handwriting is garbage. Da da da. And -3. So lots of negatives. That happens. We sum these all up, -31, -34, -58. Oh my God. Okay. Then we go the other way and do the same thing. Okay, I'm not even gonna finish writing the other arrows. 5, 16, 9, and 24. Add these all up and you should get 31, 36, 52. Okay, now what you're gonna do is you're going to take this number minus this number. So negative 58 minus 52, which gives you 110. Or sorry, negative 110, but we will take the absolute value anyways, right? Then we divide this number by 2, which gets us 55. And okay, that makes me think I miswrote a digit. Negative 4, 1. I knew this was going to happen. 5, 4, 4, negative 3, negative 3, negative 6. Okay, looks like I wrote these right. Negative 16, negative 15, negative 24, negative 3, 5, 16, 9, 24, negative 31, negative 34, negative 58, 5, 16, 21, 30. Oh, this is a 54. Okay, sorry, chat. So this is 54. You subtract these, this becomes a negative 112. And then when you divide by 2, you would get 56. Yeah, there we go. Okay. But hopefully you got the idea despite my like mess up. Hopefully y'all are smarter than me and realize that before I caught myself just now. But yeah, okay. That's 9, 10, 11. 12, find the measure of angle ABC. Okay, there are so many different ways to do this problem. You can like I used my shoelace formula and I actually had it modified so that it would do all the angles for me. So I could literally plug this into like I could plug these points into a shoelace formula and get questions 9, 10, 12 immediately. So there's that. If you draw a triangle ABC, you can calculate the side lengths and then use the law of cosines. But what I'm thinking may be a cool way is to use vector math and use dot products, especially because dot products I think come up way more often than you would expect them to. So it's pretty good to know. I'm like debating if I should send this out to just Allen kids or everyone. But since I am saying that, I will just send it out to everyone because I'm a nice person, I think. Okay. So what we're gonna do is we're gonna write out two vectors. This vector right, oh my God, I can't even write a straight arrow. Okay, whatever, close enough. So this vector, we're gonna do is we're gonna write from B to A how far it goes left, right, and how far it goes up, down. In this case, goes 5 to negative 4. So our vector here is negative 9, comma, negative 3. Okay. Then from B to C, our vector, oh my God, I should pick a darker color. Our vector is negative 1, comma, how far does this go down? Negative 7. Okay. So now what we're going to do is we're going to take the dot product of these two vectors. And what the dot product formula says, again, I need to be able to type some of this stuff. What the dot product formula says is that for two vectors A and B, A times B, or times is the dot product, is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. So to take the dot product, what we do is that for each of the dimensions, we multiply the values. So we multiply the x's, we multiply the y's. If there's z's, we multiply the z's, so forth. So in this case, our dot product is negative 9 times negative 1 plus negative 3 times negative 7. So this is 9 plus 130, right? So we have 30 is equal to the magnitude of A, and magnitude of A is just the size of the vector, which is actually just Pythagorean theorem. So the square root of 3 squared is 9, 9 squared is 81, so 90, times the magnitude of B, which should be 50, squared 50, times the cosine of the angle. And we get the cosine of the angle is equal to 30 over the square root, like this product, so square root of like 4,500 or whatever. And if we take the arc cosine of this value, so this is in radians, convert that to degrees, 63.435, and bang, right there, that's 12B. Yeah, okay, perfect. Okay, just getting those four questions took me 9 minutes. Actually, that's faster than I thought it'd be. But okay, cool. So question 13, consider four consecutive even numbers. The product of the first and last is 9 to the 52. What's that alarm? whatever. Find the sum of the second and third numbers. Honestly, you could just brute force this, I think. I think you could just brute force this. And there's a bunch of answers that I think don't work. Like 60 can't be the sum of two consecutive even numbers, right? So that's something you can do. Because for instance, like the closest two numbers would be 29 and 31. That wouldn't work, right? So 60 and 64 you could actually eliminate. And if you wanted to, you could brute force on 58, 62, and 66. The better idea though is if we rewrite these numbers as n, n plus 2, n plus 4, n plus 6, we're saying that n times n plus 6 is 952. Now, if we use our handy dandy equation solver, okay, we solve this, we get 28. That means our lowest number is 28. And yeah, lowest number is 28. That means our second and third numbers are 30 and 32. Thus, their sum is 62. 13C, please. Okay, done. Okay. 14. Jeff and John mow a lawn together in 4.5 hours. If Jeff could do the job on his own in 6, how long does it take John? Okay, so John's just slow, bro. That guy guys need a lock in. Okay. This is a formula that I think a lot of people should just memorize. And I'm gonna type this out. It looks way better if you actually see with the fraction bars. But the general idea is that when you have two people working at that take this different times to do a task, there's a way you can find how long it takes them to do it together. So let's say Jeff takes time, sometime A, right? That's like 3 hours, 20 minutes, whatever. John takes time B. Together, their time is the reciprocal of the sum of these reciprocals. So in this case, what we have is that their time together, 4.5, is equal to 1 over Jeff takes 6 plus 1 over B, right? And then we would solve this. We take the reciprocal of each side. We have 1 over 4.5 equals 1 over 6 plus 1 over B. 1 over B equals 1 over 4.5 minus 1 over 6. So then if we take the reciprocal of that value, we get 18 hours. Bro is slow. This is coming from me. Okay. Don't close that yet. I don't know why my messages. I don't know why Sublime is open. I haven't used it. Whatever. Okay. Question 15. Not even a quarter of the way through this test, unfortunately. Okay. Hopefully y'all had time to read the question, except because of this light glare, it appears I cannot figure out how tall the building was. Let me see if I can figure it out from reverse engineering. Let me use my handy dandy calculator. Okay, yeah. So it's 88. So the building is 88 feet tall. So what the idea is that this is literally just recognizing, are you able to recognize proportion, right? Because your height should be proportional to how long your shadow is. Obviously, at different points in the day, that proportion will be a different like scale factor, but it will always be proportional. So in this case, what we have is that the ratio between the building's height and the building's shadow should be equal to the ratio between our heights, which is 5 and 7/12 feet, divided by the length of the shadow. Hopefully, I don't need to explain how to do this, but when you do solve it, you will get 2.35. Is that what I said? Yeah, 2.35 feet as the answer. These green walls are so interesting because I'm like one floor up, and the ones on my floor are blue. So pretty cool. Okay. Given, wait, y'all get to see the fun part where I draw really bad diagrams and still manage to get these questions right. Because, guys, remember, it matters how in scale your diagram is. All that matters is that you can do math. Because remember, we are mathematicians, not artists. If we were artists, Uh, I don't know. I'm actually not really sure what happened, but something would. Okay. So we're given a circle of diameter AD, and BC is parallel to AD. Since it is parallel, it must be a chord, which means not the diameter, right? Because it has to be parallel. If it was perpendicular, there's a chance. But yeah, so I think there's two here, which is perfect. Can I draw a clean circle? Oh, I can't. My face is blocking the fixed. Okay, here's our circle. Um, here's a line. Here's a line. Oh wait, it's parallel. I might be a bit slow. Okay. Obviously, I don't know if the lengths themselves are correct, but you have a really nice diagram. You're welcome, guys. Okay. What are we given? So O is here, A is here, D is here, B is here, C is here. Okay. And we know AD is 26, BC is 24, and the measure of angle AOB is less than 90. Okay, so this gives us a lot of information. For one, this clarification is actually very important. I remember on the UIL SAC test, like the student activity conference test, I took the math test and there was a question that was kind of similar concept and didn't have this clarification. So I ended up getting a valid answer, but they used a minor arc instead of a major arc that I was not aware of. So I remember being very mad about that. Okay, so this does give us a lot of information. We know that I'm gonna draw this immediately because I know that this is gonna be coming. What we know is that this diameter is we know that the diameter is 26, but our radius is 13, right? If the radius is 13, OC must be 13. Yes, I did just write that 3 upside down. I never do that. If I draw this down here, this is a right angle. We know that this length here is 12. Just call this some point like Q or something. I don't feel like writing it. And this is 5. Okay. Now, what do we have to figure out? First question, if E is the midpoint of BC, then OE is what? Wow, it's almost as if this is our midpoint and we did just calculate that. Yeah, so this is literally just comes down to knowing, like observing that this is a radius. We know this is just a perpendicular bisector, and this will be a perpendicular bisector because these are parallel chords. Any two, if you have a diameter and then, yeah, if you have a diameter and then a chord parallel to it, a line, like I forgot what I was gonna say. Just pretend I was gonna say something smart, but like, just this is gonna bisect it perfectly. This is the point. If I draw a perpendicular line through AD, which is obviously perpendicular to BC, then it will bisect BC. That is what I meant to say. I do remember now. Okay, so we already know this is fine. What is the area of sector BOD? This sector, oh, that's a weird angle. Interesting. Okay, sector BOD. Okay, so because I already drew the triangle here, we're gonna find the area of the sector AOC instead. Hopefully y'all can see that because of reflection, it's the same thing. So AOC, first we need to find the angle. We know that this angle here must be 90 degrees. And then as for this angle, we just use we can use arc sine, arc cosine, arc tangent, whatever suits you. And okay, I'm gonna do this in radians, and you'll see why in a sec. 1.176 radians. Okay. Okay, I may just randomly dip in a bit because I need to fill out my water bottle. Okay. So if we're trying to find the area of a sector, if we know our angle in radians, is area equals 1/2 r squared theta. I know this is not sine theta, this isn't cosine theta, it's just theta, which makes stuff a lot easier. So what we do is we have 1/2. Actually, I'm going to do this calculator. It doesn't really matter. So we have 1/2 times r squared. R squared we know is 13 squared times theta. In this case, we know 90 degrees is pi over 2 radians plus the 1.176 that we just found. Equal to 232. I just realized y'all can see my bookmarks, but there's nothing embarrassing on there. Okay, 232. Yep, right there. C, 17C. Perfect. Okay. Arc length of the minor arc BC is what? Okay, minor arc BC. So this length right here. And what we can do is we can observe that, oh my God, we have this thing right here. And this angle is equal to this angle. And the formula for arc length is just r theta. I don't know why it's s. I've always wondered that, but never bothered with it. I guess it's like a side, but that's like dumb. But anyways, so here we have our radius is 13, and theta is just 1.176 doubled. So 32 times 1.176 doubled. 13, sorry, I lost my train of thought. 30.576. Right there, D. 18D. Okay, I'm gonna take a pause on this, fill up my water bottle, and then I'm gonna start this in a bit. Y'all will see a continuous stream, doesn't really matter. But yeah, okay, let me stop this real quick. Okay, guys, I'm gonna be honest with you. I took like a 10-minute break, and I think half of that was just listening to K-pop, just like relieve myself. But I did get more water. Okay, let me. Oh yeah. Okay, let me. Multitasking. I did figure out that the first 18 questions took 36 minutes, like 2 minutes a question, pretty fine. And it took up 128 megabytes of memory, which is actually more than I thought it'd be, which is weird. So I may have to do this in like chunks. Like I may do up to question 38 here and then speed through the rest. We'll see what happens. Okay, question 19. We have a well, okay. Sector of a circle that forms cone. I haven't seen these problems a lot, but I think it's really important to understand. Okay, I'm trying to think because this is something that's really hard to explain. But the idea is that excuse me, if you imagine the sector, it kind of looks like this. What you're doing is that you're taking this edge here and kind of rolling it until it hits this edge, and then you form a cone. Turning circle sector into a cone. I wonder if there's a video I can show you guys. I may have to save this for something. So y'all can see. See, and it forms a cone just like that. That's basically the idea. Kind of fun. I'm surprised that I found a video that fast. But anyways, okay. We have this, and we know that the sector has a radius of 8 feet. And if you look back at the video, just like play back if you need to, you'll notice that this 8 feet will actually represent the slant height of our cone. And the arc length of the sector is going to turn into the circumference of the base. Okay. And we have radius at 8. The volume of the resulting gallon is 1155 gallons. So first thing, we need to convert this into feet cubed, which is kind of annoying. But yeah, 1155 gallons to feet cubed. You can use side tables on this. You can be a number sense nerd and know the conversion to inches cubed. I'll do that. So 1155, this is cubic inches, 231, divided by 1728. This is the number of cubic feet. Actually, I'll just keep it here. No, I'll keep it. We'll throw it here. Okay. So this is our, what is this? Was volume. Okay. So we know our slant height, which is usually represented as L, is 8. We know radius is greater than 5. And we need to figure out what our radius is. So let's call our radius some variable r. We know that height must be equal to the square root of our slant height minus the square root of our slant height squared minus our radius squared, I that. So in this case, 64 minus r squared. So our cone's volume is 1/3 times pi times r squared times h. And then all we have to do is just solve this. So 1/3 pi, I'm gonna use Desmos. 1/3 times pi times r squared, we'll use x squared times h, which is the square root of 64 is h x squared. Okay. Is that a McDonald's logo? Interesting. Okay. And then we just need to figure out, so this is the volume. We want it to equal that weird value that we got earlier, this thing. Okay, so you'll observe that there's two positive values. We said our radius is going to be greater than 5. So that makes our answer 7.57644, 7.6. There. Okay. Question 20. What was the central angle of the original sector? Okay, so now we know the base radius, and because of the base radius, we can now find the circumference of the base. So, okay, so we're saying that our radius of base is going to be this value right here. Circumference of the base is going to be 2 pi times the radius of the base. This right here. This value is equal to the arc length of our sector. We know S equals R theta, so therefore this value divided by our radius of 8, no, is the radius of our circle? Yeah, the radius is 8. This is our theta, right? We take this times 180 over pi gets us 341 degrees. Right there, 340.9 degrees. 20 is D. Okay. 21. How in the world did he struggle on this? Okay, whatever. Okay, so on a scaling triangle. Okay, so wait, yeah, I don't know. Okay, so we actually don't need to care about the scaling bit because based on these answer choices, we can actually eliminate 4 of them on the spot. And the reason behind this is the triangle inequality. And what the triangle inequality states is that if we're given two sides of a triangle, the third side cannot be less than or equal to their difference or greater than or equal to their sum. Here's why. If we have two side lengths, let's say we have this one here, this one here, right? If let me draw a better example. So let's say we have this and we have this, right? If our third side is too small, it won't reach. And if it's too long, it'll be too big. Because if we have, let's say our side lengths are like 4 and 3. I think it's better if I use examples. 4 and 3. Pretend that this is like two different segments. 3. If I'm using a side length of 7, then it'll be equal to this and we have a line. And if I use something like 8, you end up with like this, where it's too long. And you could use a similar case for the smaller purpose. In general, the triangle inequality is more used in the sense where the sum of any two sides must be greater than the third. In this case, the sum of 22 and 33, 55 must be greater than x. Only one of these choices is less than x. 55.2, 56.1, 57, and 57.3 are all too big. So answer is 21A. So don't have to worry about the scaling bit. Okay. Um, triangle ABC is the right triangle there. Okay. Like these problems, like so many of these problems, let's just draw this out. That's right. ACB is 90. And remember, these never have to be to scale, just something that you can understand. D is on AB such that CDB is 90 degrees, which means that CD is what we call an altitude, specifically an altitude of hypotenuse. AC is 20, BC is 21, what's CD? Okay. Length of the altitude of a right triangle is going to be equal to the product of the legs divided by the hypotenuse. Where did I pull that from? The reason why is if we were to tilt this triangle, we could get this triangle in the same shape where the base is the hypotenuse and the height is this altitude CD. 1/2 base times height must equal 1/2 times base times height. So therefore, the product of 20 and 21 and the product of the hypotenuse and the altitude must be the same. So 20 times 21 divided by the hypotenuse, 29, 14.48, 14.5, that's our answer. Okay, 23. The area of this triangle is shown here. What is it? Okay. You can notice really quickly that these are all formed in the same way. So these are all, this is an equilateral triangle in the middle. If this is 10, this is 5, we use Pythag. This side length here is going to be the square root of 75, right? Then we just need to find the area of a triangle with side lengths of square root of 75, equilateral. The formula for an equilateral triangle area, for those who don't know, is x squared times the square root of 3 over 4. So in this case, the square root of 75 squared times square root of 3 over 4. 75 over 4. So 32.47, that gets us right there, A. Okay, sweet. Consider this function if f of 3 is 48, b is what? Okay, this I'm not gonna write down. I think this should be a pretty free one. If you plug x equals 3 into this, you should eventually you should get something plus 9b plus something equals 48. I just saw someone in it. That's cool. You get that equals 48. You just solve for b. It's what is it? I'll let you know. It's c. It's negative 22 apparently. Yeah. The fourth term of the sequence is 7, and the eighth term is 17. Find the sum of the first 20 terms. Okay, so the distance between the fourth and eighth term is 4 terms and an arithmetic difference of 10. Since it's an arithmetic sequence, we divide, and we get that the difference between any two consecutive terms is 2.5, right? Then there's multiple ways we can go about this. We can subtract and add multiples of 2.5 to find the first and 20th term, or we can do my favorite trick, which is summations. So what we're going to do is let a sub n be like the nth term. So a sub 3 is the third term, a sub 4 is 7, and a sub 8 a sub 8 is 17. So for each of the first 20 numbers, we're just going to sub a sub x. What is a sub x? We know that if we think about this in terms of like a linear equation, because it is an arithmetic progression, we get that our linear equation should be 2.5x plus something. And we know that x equals 4 should return y equals 7. If we plug it in, if we like solve for it, we would get negative 3. I'm going to write this down and then hopefully it'll make a bit more sense. But yeah, if I plug x equals 4 into this, 2.5 times 4 is 10 minus 3 is 7. And then for 8, 2.5 times 8 is 20 minus 3 is 17. So this is the general term, or what is called a closed form of our thing. And then we sum the first 20, we get 465 as our answer. Bam, eat piece of, not cake, maybe brownie. Piece of brownie. Okay. 26. If ax to the fourth plus bx squared plus x. Okay, even functions. Okay. So you notice that we have no way to solve for a and b, but we still have to somehow figure out this value. And the trick is this function is very, very close to being even. Excuse me. Okay, so general idea for even functions is any polynomial, if a polynomial has only even exponents, it's even, and has only odd exponents, it's odd. If a function is even, it means it's reflective across the y-axis, which means that f of x equals f of negative x. So in this case, if we just had ax to the fourth plus bx squared, then an f of 2 was 30, then f of negative 2 is also 30. But we have to consider this x term. So that's a bit weird. So what we're going to do is we're going to modify our function a bit. Why did I close Clucky? Okay, we're going to do is, sorry, chat. I did not mean to say chat out loud, but it's okay. I've like devolved since I have started rooming with, if you know, you know. Okay. So let's say we write this term here as g of x. If f of x, sorry, if f of 2 is 30, then g of 2 must be 28, just by the logic of it. And we know g of x is even. It has an x to the fourth and an x to the second, only even powers. So that means if g of 2 is 28, g of negative 2 is 28. Then we just add on this negative 2 here, and we will get f of negative 2 is 26. So in summary, we try to turn this into an even function, use the property, and then just switch back to like the original form. So that should get us 26. Okay, answer 26 is 26. Okay. Question 27, the population. Okay, so it's just a doubling problem. So what we do is, in general, anytime we have like us constantly multiplying by some factor, how low is, oh, my below battery's at 50%. Should be fine. Okay, so anytime we're doubling by some amount or multiplying by some amount every something days, the general form of the equation is, I wonder if we can use text or that may be the strat. I'm like figuring stuff out like on the fly. I decided I would do this just on the spot. Okay, so this is the general idea. So our population is equal to our initial population times our rate to some exponent. And this exponent is the time that has passed divided by the time that it takes to double or triple or whatever. So in this case, p sub 0 is 15, and it doubles r is 2 every 3 days. So after 30 days, we're going to have a 30 over 3 here. So this exponent is 10. R is 2, so 2 to the 10th is 1,024. So 1,024 times 15, should probably do that in my head, like 15,360, I think. So 27b. Yeah. But yeah, okay. Hopefully that should be enough for an explanation. Okay. 28, the graph of y equals 2 tan x over 3 has a vertical asymptote where? Okay. So in general, vertical asymptote, I'm gonna keep this open. Vertical asymptote of the tangent function, where are those? Okay, tangent function is not defined whenever cosine is equal to 0. Cosine is equal to 0 at pi over 2, pi over 2 plus any multiple of pi. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, whatever, right? Now, when we do x, the 2 times the tangent of x over 3, this over 3 changes the period. And what happens is that it should expand the period by 3. I think that sounds right. I gotta graph this. Okay. So here's tan x, here's tan x over 3. Oops. Yeah, it's going to expand it by 3 because the general idea is that if you have like tan of bx, then the period is pi over b, right? In this case, this b is actually a third, so the period turned from pi to 3 pi. So we notice that all our asymptotes are going to get 3 times as far from the vertical axis. So instead of at pi over 2, 3 pi over 2, 5 pi over 2, we get to 3 pi over 2, 9 pi over 2, 15 pi over 2, these kind of numbers. 9 pi over, so yeah, 9 pi over 2d. Okay, perfect. That's another page down. Okay, so I'll probably do one more page and then take yet another break just to cool myself down. Consider this sequence. Find the sum of the first 12 terms. Okay, usually when you see these sequence problems, immediate thought should be it's either arithmetic or geometric. I have seen one where it was like really weird factorial stuff on Districts 2023, I believe, but there's always a weird case, right? So you think geometric, you think arithmetic. In this case, this doesn't look geometric because you shouldn't, this doesn't look arithmetic, sorry, because you shouldn't be going from an integer to a fraction. It's probably geometric. And we notice that if to go from 60 to 36, we should be multiplying by 3/5. To go from 36 to 108 over 5, we're also multiplying by 3/5. So this has to be something involving 3/5, something times 3/5 to the power of something. So we note that our first term is 60 times 3/5 to the power of 0. 36 is 60 times 3/5 to the power of 1, and so forth. So for the first 12 terms, we can use this summation thing again. So for our first 12 terms, we have, in general, 60 times 3/5 to the power of x minus 1, because our first term is to the 0th power. We add these, 149.7 becomes our answer, 29a. Okay, it's been 14 minutes. I've gone through how many problems? Like 12 or something? Honestly, not that bad. Okay. Wait, no, more than that. Whatever. Okay. 30, find the measure of the angle between these two vectors. Okay, I did explain dot products earlier, so I will just run through this really briefly. Take the dot product of this vector. So 2 times -4 is -8. 3 times 5 is 15. -1 times 2 is -2. So this is just 5. Right. Yeah, 5. I don't know why that took me so long. I'm washed. Is equal to the magnitude of the vector, so 4, 9, 1. So square root 14. Magnitude here is going to be 45 times the cosine of the angle. And then what we do is we would just solve this. And we have 78.5. 30 is A. Yeah, I did speed run through that, but I did explain it earlier, so I think it's true. Okay. Consider a circle centered at the origin and tangent to the line y equals -5x plus 4. Find the area of the circle. Oh, this is an interesting problem. I'm not sure if I'll be able to do this one. Okay. Um, -5x plus 4. Is that what they said? 5x plus 4. This line isn't even drawn right. Oops. Okay. So we have this and we have some circle. I'll just say like 1 squared, just like get an idea of 0.8 squared. So something like that. Um, what would be the idea? Oh, I got it. Okay. See, sometimes you need these diagrams and it really helps you figure it out. Okay, so what our idea should be is that our line is a tangent, right? What does it mean? It intersects the circle exactly once at a right angle. But at a right angle relative to what? It's going to be a radius. Radius from 0 to here. This should be a right angle. Okay? Meaning, if our length here is -5, y equals -5, we need our radius in this context. It's perpendicular to our radius with a slope 1/5. And since the radius must pass through the origin, this would just be the formula for the diameter we're considering. So this right here is the point of tangency. This point is going to be a distance r away from the circle. So all we have to do is just figure out how far away this is from said circle. And if we do that, we get this. So 0 point was actually not that far off. Yeah, and see, there you go. Now it looks way better. And then all you have to do is just figure out what the area of this is. So pi times the radius squared, 1.933. Okay, there we go. I think I might have panicked way more about that like in a test, but it's okay. Consider this circle center. Okay, interesting. Normally for these problems, okay, I'm gonna dip real quick. Okay, I'm back. These freaking bums at Jester are always knocking on the doors of the study lounge asking to be let in. Like, what if you just had your card or just got on your floor and used the stairs? But like, the gears are not turning. Okay, I'm honestly not even gonna cut that out from the video. Like, I don't really care enough. I'm too tired. I've never done video editing. Okay, so for these problems, usually you're given the standard form and you have to find something else. In this case, the other way around, which is actually way easier. So what do we know? Center of the circle is -3/4, so x plus 3 squared plus y minus 4 squared equals the radius squared. So in this case, it's 81. All we have to do now is just expand this. X squared plus 6 is 9 plus pi squared minus 8y plus 16 equals 81. We move some stuff over. We get x squared plus y squared plus 6x minus 8y minus 9 plus 16 is 25. 81 minus 25 is 55. 55. Who's texting me right now? Okay. Equals 0. Now you just need to figure out what a plus b plus c is. So 6 minus 8 minus 55. Negative 57. That, I'm so washed. Chat, what do you think we did wrong here? X plus 9, y squared minus 8y plus 16. 9 plus 16 is 25. Ah, it's negative 56. Maybe I should actually get back into number sense just so I can do basic arithmetic again. Okay, 6 minus 8 minus 56, negative 58. I swear I can do these problems. It just takes me like a sec. And I'd use a calculator on this, so there's no arithmetic flaw. Okay, 33. There are some pretty funny ways to do this one. Okay, so for those that don't know, this is actually a hint at the limit definition of uh the derivative. So this is actually asking, what is the derivative of the secant at pi over 3? If you don't know this, you can unironically just plug in a really small value of h and your calculator will allow it. But on the TI-84, if you want to find a derivative, alpha f2 here, x, there's no secant function, so we'll just do 1 over cosine x. Oh my, x at x equals pi over 3. We get this, and hopefully you can like bash out with the answers and recognize that this is equal to 2 times the square root of 3. Yeah, because it's square root of 12. Okay. How many 3-digit numbers can be formed such that the sum of the digits is 6? Okay, case-word. Trivial case-word. All these numbers must be written in the form of 1xx, 2xx, 3xx, 4xx, 5xx, 6xx, because anything more will require a negative digit. The only number that works here is 600, so we have one option. For 5, we can either have 510 or 501. So I have two options here. 4xx has 402, 411, or 420. So 3 options. And you can tell that this is just going to scale up. This is 4, this is 5, this is 6. Some of the numbers from 1 to 6 is just 21. Okay, where are these text messages coming up? I don't know. Okay. Multiply 6 times cis. I don't know if you say cis. 6 cis 15 times negative 4 cis 135. Okay. So for those who don't know, cis of x means cosine of x plus I times sine of x. That's all it means. And what's really cool about this is that the cis of x, cis of theta, is equal to e to the power of I times theta. So in this case, cis 15. I do believe I have to convert these into radians or else my calculator will blow up. So 6e to the power of I times 15 degrees would be pi over 6. No, pi over 12. Oh my God. 12 times negative 4e to the 135. So I times, what's 135? Should be 3 pi over 4. Okay, so we do this, and it actually converts into imaginary form for us. So we have a negative 12i. This 20.78, I believe this is 12 square root 3, but of course you should just bash this out. So you have 12 square root 3 minus 12i. right here, C. Bingo. Okay, 36. Which of the following equations in rectangular form can be written as r minus 12 sine theta equals 0? Okay, best way to do this is just actually figure out like I'm blanking. Like actually like convert this. So what we can do here is here this is r equals 12 times sine theta. Okay. Let's go ahead and square each side, maybe? No. I have a better way. I have a better way. Okay. So recall that there's a bit of parametric stuff. Sine of theta is equal to r times cosine theta. No, let me write this down. I'll remember. X is equal to r times cosine, and then y equals r times sine. So this sine theta can really be rewritten as y over r. Move it, this becomes r squared. This is just multiplied by r on each side. R squared is just x squared plus y squared. So that means that we have x squared minus 12y plus y squared equals 0. Option B. Ba 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 ba. Okay, 37. A dealer in a card game asks three jokers with 13 of each of them dealt a five-card hand. What is the probability that his hand contains exactly two diamonds? Okay, the way I usually do this is figure out how many hands have two diamonds and how many hands exist. Okay, so the number of hands that exist is the easier part. We have 55 cards and we need to choose five. So we just use 55, choose five. Okay, what about the top? We know that we have to pick exactly two diamonds, but all our diamonds are distinct. We can actually distinguish between them. So, out of these 13 diamonds that we have to choose two. Oh my God, let me switch tabs. So 13, choose two. And then as for the remaining two cards, we can't use any of the more diamonds. So instead of having 55 options, we would have subtract off the 13, 42 options. And out of these 42, we must choose another three. So this numerator is the number of hands with exactly two diamonds. Bottom is total. Divide those, and 25.7% is just your probability. So 0.257 right here. And 38, last one before I take that break. Find the distance between the plane and the point. Okay. Um, you'll also see questions where it's like find the distance between a line and a point. Very similar formula. Just note what the difference is. You should be able to see it. Okay. So what we're going to do is we're going to move the 6 to the left side so that it's x minus 4y plus 2z minus 6 equals 0. And we're going to calculate this value at the point 0, negative 8, 3. There's a whole proof for why this works. I actually have it written down somewhere, I think. I don't know, wait. I can like find it and maybe able to find it. Tick tick boom. Supernova. Is this? Oh, okay, yeah. Um, I don't know if y'all obviously cannot maybe read that well, but I do have the proof. If anyone is interested, I can probably like upload this to Google Drive and like just put this in the comments of the video. But yeah, very jank parametric proof. And that's for line to a point, but it's same idea. Okay. So for here, again, we're just finding the value of this thing at this point. So we have x minus 4y. So we have, you'll see the by the fraction of it. So x minus 4, y is negative 8. Oh my God. Negative 8 plus 2 times z minus that 6 that we had. Okay, and we're going to divide this. What we're going to do is for each of the coefficients, we're going to square them, sum them, square root. So for a line, which is just ax plus by equals c, you're going to see this looks really similar to like a Pythagorean setup. So here we have 1, negative 4, 2. So we're going to do the square root of 1 squared plus negative 4 squared plus 2 squared. And that gets us this 6.98. And that would be our distance 7.0 right here. And then you would notice that the only difference is that in a linear equation like ax plus by equals c, this term won't exist and then this term won't exist. But otherwise, it's the exact same formula. So that's that page. Looks like I have 22 questions to go. Hopefully some more calc and stats. Those are going to be a bit more fun. But yeah, time to rest my foot. Let me stop this. Okay, part 3, 22 questions to go. My battery is on 41%. Time to lock it. I've never had my throat feel sore, but it's okay. This is for the better of the public, I think. I don't know. I'm making stuff up. I need to double check something. Y'all are gonna see like literally the same video, but I need to double check something very important. Could y'all ever see my notepad when I was typing stuff? Because if not, that's a problem. I just realized y'all have not been able. Oh my God, wait, I've been wasting my time then. Oh my God. I don't know why I've been sharing the window. I should have been sharing the screen. Okay, I think it's fine. I'll just do the desktop for this one. But yeah, hopefully a lot of the stuff like y'all can at least understand from me saying it out loud and then worst case you Google it. Worst case, if I'm actually in the mood, I'll just re-record some stuff. That's too much work. It's okay. It was the easier stuff that I messed up on. Okay. 3940 sets off his hike from the lodge at a bearing of South 74 West. Okay, I gotta double check this stuff. Hmm. I'm sort of high switch to this thing. Okay. So it means that South 74 West, you start south and then you go 74 West. So if you go Okay, so what we want to do is we want to convert these into polar angles, as in angles like some distance away from the positive axis or like far right axis. So if we go south and then 74 west, we're going to be 16 degrees off of the, excuse me, 16 degrees off the negative x-axis plus the 180 puts us at a total of 196 for this angle. Let's write this stuff down. I knew I should have just switched to text edit. Like I didn't even make the connection that like, oh, I didn't even realize like the window did, but whatever. Okay, so this angle is really 196 degrees. Okay. And then okay, I'm sorry, this is bothering me so much now. I need to double check. Yeah, I just like stop my recording. Let me do that. Okay, I finished watching myself. I think it's close enough. But you know, y'all be the judge of that, obviously. Okay, so like I said, this is 196 degrees. South 22 west, we use the same logic. This 22 west means that it's gonna be 68 degrees off the negative x-axis plus 180 is 248 degrees. Okay, so there is some really powerful math that we can end up doing here. Okay, so we can use those cosine and sine form. If you recall earlier, I said that like for parametrics, r cosine theta is x and r sine theta is y. You can think of r as the distance he travels. So in this case, the total x distance that he travels is 1.3 times the cosine of 196 degrees plus 2.6 times the cosine of 248 degrees. Okay, so this is the x, I'm just put this as x. And then if I copy this down and change these to sines, this we can store in y, and then that's the y distance. So then to find the distance from the lodge, well, think about it. He starts the lodge he starts at some origin. So that's what we're considering this as. So then x squared plus y squared gives us 3.55, 3.6 miles as the total distance. And as for the bearing, this one, it may be helpful if you draw this out, but so negative 2.22 and negative 2.77. So negative 2.2, negative 2.7. If I'm going to use the absolute values for these and just take the arctangent. So the arctangent of the absolute value of y over x, which actually since they're both negative, it's just y over x. What? Oh, did I never store this in y? Am I bad? No, I did. Huh? Hello? Yeah, okay, I did. My calculator decided to mess with me. Arctangent of this, and we're gonna want degrees, so times 180 over pi means that 51 degrees. So that means that this angle here is 51 degrees. If this is 51, that means that the angle with the vertical is 39, meaning that if we go, oh, okay, this is how far he is that way. So we want to actually go the, oh, I just realized negative 2.7 is not up, it's down. That makes more sense. Okay, better diagram. This is the 51. And I mean, as you can tell by now, the answer is going to be this 39 here. And what the idea is that this is the vector he has to move along. And then that vector makes an angle of 39 degrees with the north. So the vector is going to be north, but then 39 degrees east of north. Hence 40 is B. I'm going to stop like just brain farting. 38%. Okay, lock in, lock in, lock in. Which of the following is one of the three cube roots of 3 root 3 of the 3 root 3 apparently? Honestly, just cube each of these, that may be easier. But you can also use De Moivre's theorem. And De Moivre's theorem, the general idea is that if we have 3 root 3, 3 root 3 can be written as, okay, and now I'm going to use my notepad, but again, also enunciate stuff. We can also rewrite this 3 square root 3 times, if we use Euler notation, e to the power of I times 0, where 0 is that angle. When we take the cube root of this, the cube root of 3 root 3 is just square root 3, and then times, and you might be thinking, oh, it's just e to the I times 0 as the cube root. The problem with this is that we have to consider that angles are cyclic, like the way they work. So for instance, rotating pi over 2 is rotating the same as 5 pi over 2. So since we're dividing, a cube root is dividing by 3, we have to consider all the each of the 3 values that it could like cycle around. So 0 works, but if we go a third of the distance from 2 pi, so 2 pi over 3, so 0 works, 2 pi over 3 works, 4 pi over 3 works. And then if we add another one, 6 pi over 3, that just goes back to 0. So it's the same thing. So 0, 2 pi over 3, or 4 pi over 3, any of these angles when plugged into this will make a cube root of the 3 times the square root of 3. Test each of these and figure out which one belongs. That's all. Okay, if I don't know why I deleted that, whatever. If A represents a digit 0 to 9, oh my God, okay. What if they just didn't do this? This one, I'm not even gonna bother fully writing out, but the idea is that you should be able to convert each of these to base 10. So the first one is 6 times 8 squared plus 8a plus 5. The second one is, sorry, 3 times 6 squared plus 6a plus 2. And this should equal, if you convert this into binary to decimal, like base 10, 1 plus 2 plus 8 plus 32, 61, 82, 56, 512. So the sum of these two is equal to this. Use equation solver, solve for A. As you can tell, I'm kind of on a bit of a time rush, but it's whatever. Okay. How many distinct? Okay, so here's the idea. Since they are indistinguishable, like the marbles are all the same, right? The 8 red marbles are all the same. So what we want to do is we pick one of our colors. Let's say we want to place all the 8 red marbles first. Out of these 16 spots, we have to choose 8 to put them in. So 16, choose 8, and out of the remaining 8 spots, we choose 5 for the yellow, and then the other 3 spots just go for the green. And it doesn't matter which one you use. I use red and then yellow. If I use yellow then green or green then red, it'll always be the same answer just because, it kind of has to. Otherwise, it wouldn't really make sense. And then, I mean, if you solve for this, you get 720, 720. Okay, that scared me because all the answers will be bigger. 43C, yep. Okay, graph intersects there. Okay, so it intersects here at, I'm guessing that's 3, 4. Because they have three intersects at 3, 4, and 5, 0. So you can make like a line for that. 3, 4, and 5, 0. So it's up 4, left 2. So y was negative 2x plus 5 over 2? Nope. 10? Yeah, and then 3, 4 should be on it. Okay, and then we also know that 3, 4, negative 4, sorry, 5, negative 4, and 6, negative 2, maybe? I can't really tell from this image. I'm gonna be honest. 6, negative 2 all exist on the quadratic. Now, you could use quadratic regression, um, but another way you can do it, so you have 5, negative 4 as the vertex. 5, negative 4 is the vertex. And then there should be some constant here so that the point 6, negative 2 is on it. I wonder if this is how I can figure out. 6, negative 2 and 6, negative 3. It's one. Oh, 6, negative 3 is already there, but it doesn't intersect the line. So I guess that has to be 6, negative 2. That's good logic. If I plug this in, I could just figure out that 2 would be the thing. You just plug in 6, negative 2, you solve for that, whatever this A value is. Now you have two equations, and you have to figure out, you find where they intersect, which honestly you can just tell without even looking. You can kind of just hope that it works out because it says that all the points are integer coordinates. So you just figured out 3, 4, and 6, negative 2. Their distance is just going to be Pythagorean theorem. Square root of 3 squared plus 6 squared, 9 plus 36 is 45. Square root of 45 is going to be, I don't know, like, it's 6.7. Okay. And 5 comma b is a focal point. Okay. So we just said that this number out here is 2. That means that our focal point distance, like the distance between our vertex and our focal point, or the distance between the vertex and the focal point is equal to the distance between the vertex and the directrix, which is equal to 1 over 4 times this 2 value here. So in this case, it's 1/8. The focus is going to be like within the parabola. So if our vertex is at 5, negative 4, our focus is going to be 5, comma, negative 4 plus this 1/8, which in this case is negative 3.875. 46, the area bounded by the graph of the line on the parabola is what? Okay, integration. Call this f of x, call this g of x. And what we're going to do is we're going to integrate between their intersection points, which is 3 to 6. Okay. And what we're going to do is for each of these infinitesimal points, we want to find like the height of the region. And the height of the region is going to be our upper function minus our lower function. So in this case, it's f of x minus g of x. And then when we integrate that, we get 9 as our answer. Hopefully you can figure out where the integral is and all that stuff in your calculator. You can definitely just Google this, worst case. And okay, last question. If the area bounded by this graph is revolved around x equals 1, what's the volume? Okay, shell integration. Shell integration. Okay, so shell integration, the idea is 2 pi times the integral from that bound of our function of r times our function of h dx. H is going to be the height of the region, and r is going to be the distance from that infinitesimal point to x equals 1. So we notice that for the 3 is a distance of 2 away, 5 is a distance of 4 away, 6 is a distance of 5 away. So the radius equation is just x minus 1. Right? It's just going to be x minus 1. And then our height function is going to be equal to the same height we used already, so f of x minus g of x. 198 is our answer, 47e. I'm getting through this a lot better than I thought I would. Okay, 48. Huh. Consider this graph, y-intercept of this line. Okay, so yeah, this is just implicit differentiation. For those who don't know, implicit differentiation is basically the idea that we can literally just do this normal differentiation. We have to consider that we don't know dy over dx, which is the derivative of y with respect to x, aka the slope. So in this case, xy cubed, we use product rule. So x times the derivative of y cubed, which is dy squared times, I'll call this y prime instead of dy over dx, plus y cubed times the derivative of that, plus the derivative of xy, which is going to be equal to xy prime plus y, is equal to the derivative of the right side, which is 0, because we want to differentiate both sides. We know that the y-intercept of the, and we want to figure out the y-intercept of the line tangent to the curve at the point 7, 1. So 7, we plug in a 1 here, we plug in a 1 here, plug in a 7 here, we plug in a 1 here. So we get, this is 21y prime, plus this is 28. And then, okay, we get this. So that means y prime is equal to negative 1 over 14. Then we use slope-intercept form, y minus point slope form, sorry. Okay. Then the y-intercept, so when x is 0, we plug in here, negative 7, times that is a half, plus 1 is 1.5. D. 49. Radioactive element carbon-14 has a half-life of 5730 years. Both of them have lost 42% of their carbon-14. Okay, so this works kind of similar to the other problem I was mentioning. So let's pretend that we originally started with 1 gram of carbon-14, meaning that after we lost 42%, we have 0.58 grams. So we say that 1 times our ratio, which is a half, to the power of x over 5730, where x is our time and the half-life is 5730 years, how long it takes for it to halve. And we just need to figure out at what time does this equal 0.58. Now, normally you wouldn't graph this. You could just, what you can do is if you take the log base a half, which is slightly cursed, of 0.58, that's equal to x over 5730. So 5730 times this is 4503. That's your answer, 4500. Okay, again, so sorry for speedrunning through this, but I don't want to go back and grab my charger and my Mac is at 34%. I do have multiple outlets here, but too much work. And I'm also upstairs, so I'd have to go down to 50. When evaluating x to the fourth times ln x, their integral, using IBP. Okay, IBP, as you can see here in this very nice cursive, there's 2 different acronyms you can use. You can use lipet, L-I-P-E-T, or liate, L-I-A-T-E. I learned as lipet. I like lipet. It's way funnier to say. What lipet means is the following phrase: logarithmic functions, inverse trig functions, polynomial functions, exponential functions, trig functions. And this is to help you choose a value for u for integration by parts. I'm not going to explain what integration by parts is because that will take a while. If you do want a separate video or like you can find separate resources on this. If you want a video, I guess let me know. I don't know how often I'll be doing this kind of stuff. But yeah, so if we use limit, we notice that our two functions here are x to the fourth and ln x. This ln x here, since it's logarithmic, it takes priority as our u value, which means dv must be the other value, x to the fourth dx. Pro tip, make sure your choice has this dx because I have seen tests where they will exclude this dx on some choices. Like they'll have x to the fourth dx and x to the fourth, both as choices. And you have to make sure this is dx. Okay, 51. Find the points, find the sum of the points of inflection. So points of inflection are just going to be the values where the derivative, it should be where the derivative changes sign. Is it derivative or second derivative? Let me ask, I need to Google this. Yeah, where the derivative changes sign. So if we differentiate this, we get 18 plus 8, sorry, 18 minus 18 sine theta. So our function is going to look this. And it's going to be on the range. How does this all look like? So we want to find the derivative 18. This freaking guy Chris is actually like an NPC, I swear. Oh, okay. I trolled by reading. It is second derivative. That makes way more sense. But hopefully you would realize that when you make the first derivative, it never changes sign. It always stays positive or zero. So that's kind of weird. So if we take the derivative of this twice, derivative of 18x is 18, derivative of that's zero. Derivative of 18 cosine x is negative 18 sine x. Derivative of that's negative 18 cosine x. So this is the function of our second derivative. And we just need to figure across from 0 to 2 pi exclusive, when does this change signs? So this changes signs here at pi over 2 and 3 pi over 2. Sum those pi. So C. 52. Interval of convergence. Interval of convergence relies on what's called the ratio test, which requires us to find here. Also search this ratio test just so I can explain it. The general idea is that if we have a bunch of terms in a sequence, right? Let's call these terms a sub n. Then if we take the ratio of any two consecutive terms as n approaches infinity, like the infinitive term and the infinitive plus one term, if if this ratio is greater than one, it has to diverge, which means that it's going to it has to diverge because that means we're adding bigger and bigger values on. If it's less than one, it's going to converge because we're adding smaller and smaller values. And if it's equal to one, it's inconclusive, which means that we have to test these endpoints of like our potential interval. So in this case, we don't actually, oh, we actually do need to find the interval. Okay, so y'all get a good training there, but I am gonna speedrun a bit of the logic with some explanation though, so y'all can do further research. But the idea here is that we have, so a sub n is equal to, okay, I think this is right. Okay, come on, load. Okay, so what we're gonna do is we want to find the ratio, we want to find the limit as n approaches infinity of the ratio between these terms. So we're just gonna add a bunch of n plus ones here. And then when we divide this out, what's going to happen is that a bunch of this stuff is going to cancel. So like for instance, x minus 2 to the power of n plus 1 over x minus 2 to the n is just x plus 2, or x minus 2, sorry. Then, okay, I gotta remember how to do this stuff. I believe that's right. So we get this limit, right? We should observe that the limit as n approaches infinity of n over n plus 1 is just going to be 1. So we can just take that out of the way. Then approaches infinity is going to be 0. Here. Let me write this down and figure out where I messed up. Because there's a chance I may have just written the limit wrong. And I was hoping I didn't do that so I would save time. But sometimes you do make mistakes. The good thing is that you have plenty of time during this to recover. Okay. X minus 2 over, oh, this shouldn't be over n. Sorry, guys. Yeah, because okay, so the x minus 2 to the n plus 1 over x minus 2 to the n is x minus 2. Then we have 2 to the n plus 1 divided by 2 to the n, which is 2. But because we were dividing, this ends up in the denominator. And then the n over n plus 1, that does become 1. Okay, so we want this value. Our goal is that we want x minus 2 over 2 to be less than 1. This term to be less than 1. And what we get is if we multiply by 2 and just shuffle stuff around, we should get this. Yeah, we get this. So what does this mean? If our value is between 0 and 4, it 200% converges. If it's equal to 0 or equal to 4, we're actually not sure. So we're about to test that right now. So if I plug in 4 into this, we observe that 4 minus 2 is 2, and we get a 2 to the n over 2 to the n. So those cancel out, and this term reduces to just 1 over n. And the infinite sum of 1 over n is actually a diverging series. It's a common one known as the harmonic series. You can prove this with the integral test, a bunch of other stuff. But yeah, point is that 4 is not in our interval of convergence. What about 0? Plug in 0. This is negative 2 to the n over 2 to the n, which is negative 1 to the power of n over this n right here. So instead of having 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, we're going to get negative 1 plus 1 half minus a third plus a fourth, something like this. And this, by a test called the alternating series test, will actually end up converging. So in this case, 0 will be included in the interval convergence, 4 won't. So 52 should be A. I've been looking at the answers recently, but I'm probably right. Okay, 53 just goes back to the whole idea of even functions that I mentioned earlier. Because a even function is perfectly reflective, the integral from 0 to a is equal to the integral from negative a to 0. So for instance, in this function here, we know that the integral from 0 to a of cosine x is c. So if we reflect it over so that we get the negative a over to 0, we also know that's c. So if this problem was just the integral from negative a to a of cosine x, our answer would be 2c. But we have this 3. What we can do is the 3 is only going to change the height of everything. So it just ends up tripling our result. So 2c gets tripled to 6c. And because of this like effect where it just adds a height to the result, what's a cool fact is that you can just pull this 3 out. So instead of writing this as the integral of 3 cosine, it's 3 times the integral of cosine, exact same result. And that's just one of those properties. Okay, 54. Events A and B are independent events such that P of B equals 5. Okay, I gotta make sure I do this right because I know that people did mess this up and I actually had trouble when I was helping them at first. Okay, so if two events are independent, that means that they don't like necessarily affect each other, which means that the probability of both happening is equal to P of A times P of B. Now, we recall that for any two probabilities, P of A union B, aka the probability that A or B happens, is equal to P of A plus P of B minus the probability that they both happen. If these were exclusive events, this value right here, the P, A, and B, would just be 0. So in this case, we have P of A union B, which is 0.648, equals P of A, which we'll call X, plus P of B, which we know is 5X, minus the product, because that's P of A and B. In this case, it's X times 5X, or 5X squared. So what we really end up with is a quadratic out of nowhere. 0.648 equals 6X minus 5X squared. And what we do is that if we end up solving this, like I can just chuck this in the decimals right now. And we end up getting either 0.12 or 1.08. And for very obvious reasons, 1.08 can't be a probability, except for the probability that I'm probably going to solve my data structures midterm next week. So our answer in this case is 0.12e. Okay. Number 9, I already started reading, so I know this is like stars and bars. Pizza shop has 9 choices for topping and 2 types of crust. Okay. Um, how many possible? Okay, so for obvious reasons, we can't choose 2 crusts. There's not a chance of that. So we only choose 1 crust, but we need to, out of 9 toppings, we need to choose 3 in the chance that they can be repeated. Okay, so this comes from the concept of stars and bars. I'm gonna be honest, I can't explain stars and bars that well in this scenario. So I'll give you like a similar example. So let's pretend that we had 5 balls, okay? And we want to distribute them among 3 buckets. And we don't have the requirement that a bucket has to have balls. If we did have this requirement, we can still use stars and bars, but we're gonna pretend that we have 5 balls, we're putting them into 3 buckets, and we can have 1 bucket with all 5 balls, we can have 1, 2, 2, or something, anything, right? How do we figure out how many possible ways there are, knowing that the buckets themselves are distinct? So bucket A, bucket B, bucket C, we can tell the difference between them. So here's our idea. Let's say we draw these 5 balls. What we're going to observe is, let's say I draw 2 bars, right? Pretend these are stars. I maybe should have drawn stars. It's okay. Let's say I draw these 2 bars. Okay. In this case, what we're saying is that this configuration has 2 balls in blocks, 2 balls in bucket A, 2 balls in bucket B, and 2 balls in bucket C. Something like this would mean 1 ball in bucket A, 0 in B, 4 in C. So we just need to figure out how many ways we can place these 2 bars in between or around or whatever these balls. We have, in other words, we have 7 objects. We're picking 2 spaces for the bars, and then the balls just place themselves. So it's just 7, choose 2, which I believe is 21, right? This problem follows the exact same idea. I just didn't really know how to write out that well. But the general idea is that for n choose k, where it can repeat, what we do is instead of doing n choose k, we do n plus k minus 1 choose k. So in this case, n plus k minus 1 is 9 plus 3 minus 1, which is 11. And 11 choose 3 is going to be 165. And then we have to choose our crust, right? That makes this option evil. We have to choose our crust. So we have 2 options for that. 165 times 2 is going to be 55a, 330. Almost there. 56, mean of 55 inches, standard deviation of 6 inches. And what we have to do is, okay, I thought someone was going to ask to open the door again. I was about to get mad. Okay, give me a sec. No way Justin just sent me a PDF copy of the VC1. Okay, you know what? It's cool. Thank you, Justin. You're my goat. You're my goat. You actually, I was gonna say you better win state, but I also kind of want Rohan to win state. Y'all can just tie for first, like me and Dominic did. Y'all should just do that. Uh, give me a sec. Okay, all good. Okay, so five. 5 more questions to go. Yeah, 29%. Oh, I'm chilling. Okay, so we have a height of 10 euros is approximately normal with a mean of 55 inches and standard deviation of 6 inches. And we'll figure out what percentage of 10 euros cannot go on the right. So what does it mean for a distribution to be normal? It just means that if we plot the values, the potential values with their frequency, it's gonna mimic a Gaussian Gaussian distribution, which looks like a bell curve. It's like your classic curve, literally just this loopy thing, right? So here we're told mean of 55, standard deviation of 6. Okay, so several ways we can actually not, there's not really several ways you can do this. There's a very straightforward way. I'm not gonna explain the whole idea behind it. If I was an AP stats teacher or if I had the time, I could go over, oh, finding the z-score to figure out what the z-score of that 54 inches is, using that to find the percentile, those kind of things. But in this case, we're just gonna use our calculator. So, did I just download? Oh, I didn't mean to download this. Oops. Okay. So what we're going to do is we're going to use normal CDF. Normal CDF represents the percent of values that lie between our lower and upper range given a mean and standard deviation. In this case, we're going to set our lower range to negative infinity. You could make this 0, but you shouldn't make it. It's best to make it negative infinity because the difference between negative infinity and 0 is so little, and your calculator defaults on negative infinity and positive infinity. You may as well keep it. Also, if you increase it too much, it may actually skew your answer. But yeah, so we just need them to be at most 54 inches. And we have our mean as 55, standard deviation as 6. And the important thing is there's not really any inclusivity in these probability stuff. Like for instance, if I had a continuous distribution and I said, what's the probability that I pick someone and he's 55 inches tall? The answer is technically 0 because it's not really like defined well. Like you could use a Gaussian function. This is really weird. So we consider those 0. But yeah, if we plug this in here, 43.4% of people, 43% of people will not be able to get on the ride. Okay, almost there. 57. Midpoint approximation, Riemann sums. Okay, Riemann sums are the idea that integrals were first based off of. You may have heard of the idea that integrals are like the area under a curve. We have these rectangle drawings, and that's exactly what the Riemann sum is. So it's way easier when I can just use the internet to pull up pictures for you guys. Yeah, here's the idea. So we have 4 main Riemann sums: left, right, midpoint, trapezoidal. Trapezoidal you never really use. I hate trapezoidal. But actually this is a pretty good image. Okay. So what the idea is that in our subinterval, we're gonna make these different rectangles, right? Typically, you do make these equal width rectangles. In some UIL problems, they will have uneven ones. Like I believe this one will maybe uneven, but we'll see. In this, what you do is that you take your interval and you set the height of your rectangle depending on what type of Riemann sum you're doing. For a right Riemann sum, you're going to use the right point of the interval. For a left Riemann sum, you're going to use the left point of the interval. And there's other stuff where for the midpoint, you use the midpoint's value of the interval. There's trapezoidal sums where you just make a trapezoid instead. There's the upper and lower methods where you just take the max of the two or the min of the two. And stuff like that. Okay. So in this case, we have a midpoint approximation with 3 subintervals on this day. Okay, so I think since they said midpoint approximation, that's why they didn't specify it's equal intervals, but I think it is equal in this case. So our intervals are going to be 10 to 11, 11 to 12, and 12 to 1. And these values represent people per minute. So in our first interval, which is 60 minutes, our midpoint, aka the 10:30, was 3 people per minute for 60 minutes. Our second interval was 5 people per minute for 60, and our last was 6 people per minute for 60. So 3 people per minute for 60 is 180 people. 5 would be 300, so that's 480 total. 6 is going to be 360. I forgot the number I said already. 180, 300, 360. And that gets you 840. Yeah, so that's going to be B. Why is this not? The fact that this is not sorted annoys me. Okay, 58. In a random sample of 45 15-year-old boys, the average weight was 172 with a standard deviation of 12. Find a 95% confidence interval. Okay, so the idea for this is that we have these different tests in our calculator. In this case, this is called a, sorry, test. We use this step on right here. This is going to be a Z interval. That Z interval should be, I believe. Maybe it's a T interval. I'll figure out in a sec because we will find a difference. But I think this is Z. Let's check. Z distribution versus T distribution. So Z distributions are used when the population standard deviation is known or sample sizes are large enough. So for this, we actually may want to use a T interval instead. Yeah, I forgot this stuff because 99% of the time it is a Z interval. And in the worst case, you use Z interval, it doesn't work, you can just use T interval next. Okay. So we're told that we have 45 people, average is 72, and standard deviation is 12. So average is 70, 172, 12, 45. Okay. And then we just need to figure out at a 95% confidence interval. This means that we're 95% sure that the true mean, like out of all people in Dallas, all 15-year-old boys in Dallas County, their mean weight is going to be in this range. So if we're less, or if we're more confident about it, it's going to be a bigger range, right? If I'm 100% sure that it lies between this range, I'm 100% sure it lies between 0 and like 6 trillion. It has to. But I'm like 2% sure I'm gonna pick like a really small value. Like it may exist between 50 and 51, or those are bad weights, 170 and 171, but it could be over, it could be under. There's a pretty decent chance. Another way to think about it, if I remember this right, is that what this means is that if you randomly take samples of the same size over and over again, 95% of these samples are going to have a mean in this interval. So what is that interval? 168.4 to 175.6 right here. Yeah, actually, I think I told someone. Yeah, if you're hearing this, you're gonna know who you are, I think. But yeah, I told someone and I didn't say Z interval, but I think this does actually get you the same answer. So oops. Okay, 59. I hope people do watch this. I think this will be helpful, even if I am kind of speedrunning this a bit more. LSRL. Okay, LSRL, least square regression line. This is basically supposed to be a line that approximates. There's a whole formula behind it. I'm not going to explain that. I will probably have to figure this out because I am interested in some data science stuff, so I'll be taking like R related courses at some point at UT. But yeah, it's just a regression line that gives you like an approximate way to like figure out a trends pattern and predict future values. So what we can do here is, so what we're going to do is we're going to create the LSRL, and we're going to do is we're going to plot our X and Y points. I don't know what these values are from. These old values. Okay. What are our values? 3, 12, 20. Oops. Okay. 44, 33. I forgot I can use like the keyboard. I can use the keyboard for everything, but it's like annoying. Okay. Then we can go to linreg. What we're going to do is we're going to store this in Y1 in case we do need it. And we do calculate this. So our first question was that there's a corresponding decrease of this many seconds in the time for an employee to complete an item every month. So we notice that this slope right here, negative 0.44765. Negative 0.44765. A lot of the time I will actually just memorize the number just so I can put it on my calculator, or I'll write it down because I may need to use it. So this is minutes per item. So multiplying this by 60 gets you a decrease in 27 seconds 27 seconds per month. So that's that. 60. According to the model, how many months would an employee expect to work at the company before they were able to pay an item in 15 minutes? So what we can do here is we can actually just figure out when this equals 15. We could graph this, or we can abuse equation solver. And we're going to say y of some value is equal to 15. What is y? If we solve this, 65.9. That would be 66 months. A lot. And I'm actually gonna go ahead and bring up a pretty just another point because residuals come up a lot. What residuals mean is that our linear regressions, for very obvious reasons, they can't perfectly predict a trend. So it's helpful to know whether our trend is overestimated or underestimated value. And we use residuals to figure this out. And the formula for the residual is for some point, it's the actual value minus the predicted value. I often see that as y, oh my God, y minus y hat. See, they already got me. They know me. They know me. But yeah, do I have like a picture? Okay, I guess I don't have a picture. But yeah, so your residual is just gonna be y minus y hat, actual minus predicted. So let's say, um, okay, let's say we have y. Oh, we can use on one of the examples here. So let's see what it predicts 20 months. So at 20 months, it predicts that we should be at 35.55 minutes an item, but we're actually at 36. So our actual minus our expected is our residual. And what this means is since our residual is positive, I gotta make sure I say this right. Since our residual is positive, our line is underestimated. Because remember, it's the difference between our actual and our expected. So if our expected is lower, that means we underestimated. And if our expected was higher, as in we got a negative answer, that means we overestimated. Okay, I think that's it. Yeah, that should be all 60. To people who actually watched this, thank you. I did put a bunch of time into this. 10 p.m. I need to lock in on leg day now. But yeah, y'all have a good day, night, morning, afternoon, whatever. And if I do this more, I'll see y'all next time.